Today's lesson has been brought to you by Limitless Learning TT. For additional videos as well as more information on our services, please visit www.limitlesslearningtt.com. You can email us at limitlesslearningtt@gmail.com or give us a call at 868-354-3115. Today's lesson deals with trigonometry, and trigonometry is all about triangles. We're going to look at two types of triangles. Our first case is going to be for a right angle triangle, and the second is going to be for any type of triangle. A right angle triangle is easily identified by the little box shown in the corner here. That little box represents a 90-degree angle. We have two other angles. We're going to call one theta and we're going to call one alpha. And now we have three sides of our triangle. The easiest side to recognize is the longest side, which is known as the hypotenuse. Our other two sides depend on which angle we are talking about. When we're looking at theta, the side that is opposite that angle theta is going to be this side. So that's going to be known as our opposite side. The side that is next to theta, that isn't the hypotenuse, that's this side, is going to be the adjacent side. Okay, so those are the three terms for our sides. We have hypotenuse, we have opposite, we have adjacent. If we're looking at our angle alpha, however, the side that is opposite alpha is going to be this side. And the side that's going to be next to alpha but isn't the hypotenuse is going to be this side. And this will be our adjacent side. So our hypotenuse side is always fixed. The hypotenuse is always the longest side of our triangle. Opposite and adjacent sides depend on which angle we're talking about. So that changes based on whether the angle is theta or whether the angle is alpha. So trigonometry is important in helping us find the angles as well as the sides of a triangle. In our case of our right angle triangle, we have three special functions that help us find the sides, the different sides of a triangle, or also help us find the different angles. These three special functions are known as sine, cosine, and tangent. Let's look at these three different functions in more detail. For this example, we're going to be using our angle theta. So for the sine function, we have an equation which is sine of theta, and we can abbreviate sine as sin of the angle theta. That is going to be our opposite side over our hypotenuse. So when looking at theta, that means that this side is our opposite side and this side is our adjacent side. So our function sine of theta, again, is our opposite side over our hypotenuse, which is our longest side of the triangle. Next, we'll look at our cosine function. Cosine is abbreviated by cos, so we're looking for cos of theta, and this is going to be equal to our adjacent over our hypotenuse. And our third special function that we're going to look at is our tangent function. Tangent is abbreviated by tan of theta, and this is going to be equal to our opposite over our adjacent. So let's look at an example. Our example is given that our angle theta is going to be equal to 30 degrees and our hypotenuse is going to be 10 in length. Find the length of A, and the second part is to find the length of B. So the first thing that we always want to do is put in the information that we're given. Our angle is equal to 30, so we're going to put in 30 for theta. Next, we're given that our hypotenuse is 10. we know that our longest side is our hypotenuse. So that means C represents our longest side. So C must be equal to 10. And our first part asks us to find the length of A. So A is going to be this side here. This side A is opposite to our angle 30 degrees. Therefore, we're going to use sine. Since sine uses opposite as well as hypotenuse. So we recall that sine of theta is equal to opposite over hypotenuse. Therefore, sine of 30 is going to be equal to opposite, which is A, over hypotenuse, which is C, and C is equal to 10. Now we punch into our calculators sine of 30, and that is going to give us 0.5. So 0.5 is equal to A over 10. Therefore, if we multiply 10 by both sides, we get that 0.5 times 10 is equal to A. Therefore, A is equal to 5. So now we can put that in our diagram. The second part of our question wants us to find the length of B. B is the side that is adjacent to our angle theta, which is 30 degrees. So we can use either our tangent function or our cosine function. Why? Because both of our functions, the cosine function and tangent function, uses the adjacent side, which is what we're trying to find. If we use a cosine function, we also need to know what is our hypotenuse, which we already know. It was given in our question. If we use the tangent function, we need to know the opposite side, which we would have just found from the previous part. So we can use either function, it will give us the same answer. First, I'm going to use a cosine function for our question, and then I'll also show that using the tangent function, we'll get the same answer. So cos of 30 degrees is equal to adjacent over hypotenuse. My adjacent side is B, and my hypotenuse is 10. So I punch into my calculator what cos of 30 is, and I get 0.866 to 3 decimal places. And that's equal to B over 10. So therefore, 10 times 0.866 is going to give me B. And therefore, B is equal to 8.66. So now I'm going to do the same question using my tangent function instead. So we recall tangent of theta is equal to opposite over adjacent. Therefore, tan of 30 degrees is going to be equal to opposite, which is 5, over adjacent, which is B. So I punch in tan of 30 into my calculator, and that's 0.577 approximated to 3 decimal places. So therefore, this means that B is going to be equal to 5 divided by 0.577. So therefore, B is going to be equal to 8.67 to 2 decimal places. Now we can see both answers are approximately the same. The difference in the decimal place is because we didn't use the exact figures of tan 30 or cos 30. We used an approximation. So because we used an approximation to 3 decimal places, that accounts for the difference in the decimal places of 0.01. So we see using cos or tan, we still get the same answer for the side B, which is around 8.67. Let's look at another example. Our question is given A is equal to 6, B is equal to 8, and C is equal to 10. Find the angle alpha, and then part 2, find the angle theta. We can put in the given information into our diagram. A is equal to 6, B is equal to 8, and C is equal to 10. Okay, so let's look at part 1, which is finding alpha. Now, we have 3 sides that we know, so we can pick any 2 sides that we want to work with. So let's say for angle alpha, we want to use sides A and B. So for part 1, to find angle alpha, we're going to use sides A and B. With respect to alpha, B is going to be our adjacent side because it's next to our angle alpha and it isn't the hypotenuse, which is our longest side. The hypotenuse is going to be C in this case. So B is going to be our adjacent side when it comes to alpha, and that means that A is going to be our side that's opposite alpha. So therefore, we're going to be using our tan function because tan utilizes opposite and adjacent sides. Remember, tan of an angle is equal to opposite over adjacent. In this case, our tan of alpha will be equal to our opposite, which is side A, that's equal to 6, over our adjacent, which is our side B, which is equal to 8. Therefore, tan of alpha is equal to 6 over 8. At this point in time, we want to find for alpha, which is in our function tan of alpha. In order to find alpha by itself, we have to take the inverse of the function tan. So therefore, we write that as alpha is equal to tan inverse of 6 over 8. And now you go to your calculator and find the inverse tan function. You plug in of 6 over 8, and that should give you an answer in degrees for alpha. Therefore, alpha is going to be equal to 36.87 degrees. Of course, to 2 decimal places. So we found alpha. The next part requires us to find angle theta. I have chosen to use sides A and C with respect to theta. Now you can use any one of the sides that are given if you would like to do this question on your own. It doesn't matter, you should get the same answer. So with respect to theta, if we look at sides A and C, A is now adjacent to theta, and side C, which is always fixed, it's our longest side, is our hypotenuse. So the function that uses adjacent and hypotenuse would be cos, since cos of an angle is equal to adjacent over hypotenuse. In this case, we're looking at angle theta. Therefore, cos of theta is going to be equal to adjacent, which is A, over C, which is our hypotenuse. Therefore, that means cos of theta is equal to 6 over 10. In order to find theta by itself, we need to use the inverse function for cos, and that's going to be written as theta is equal to cos inverse of 6 over 10. And now we punch in our inverse function in our calculator of 6 over 10, and we get that theta is equal to 53.13 degrees to 2 decimal places. So therefore, our theta is equal to 53.13. And in our previous part, we would have found that alpha is equal to 36.87. And this makes sense because the angles within a triangle should be equal to 180. So therefore, when we add 53.13 degrees plus 36.87 degrees plus our right angle triangle, which is 90 degrees, we get 180 degrees. So therefore, we know our answer is right. So we just looked at cases for a right angle triangle. Now we're going to explore trigonometry when it comes to any triangle. It doesn't have to be a right angle triangle. So we're going to label a triangle as such. Our angle A, the side that's opposite it, we're going to call that side little a. The same thing for our angle B. The side that's opposite angle B, we're going to label it little b. And then angle C, the side that's opposite angle C, we're going to label it little c. And we have 2 rules that we can use for any triangle. The first is known as the sine rule. The second is known as the cosine rule. So let's start with what the sine rule says. So the sine rule says little a over sine of A is equal to little b over sine of B is equal to little c over sine of C. Or conversely, sine of A over little a is equal to sine of B over little b, is also equal to sine of C over little c. The next is the cosine rule. The cosine rule says the sum of the squares of two sides minus 2 times the product of those two sides times the cos of the angle between them is equal to the third side. Let's write that down to see what it really means. So the side A squared is equal to the side B squared plus the side C squared minus 2 times B times C times the cos of the angle that's between sides B and C, which is angle A. We can rewrite this for all the other sides. Let's look at it for what B squared is equal to. So B squared is equal to A squared plus C squared plus 2 times A times C times the cos of the angle that's between sides A and C, which is angle B. And then we can look at it for the side C. So C squared is equal to A squared plus B squared minus 2 times A times B times the cos of the angle between sides A and B, which is angle C. Note that these are 3 equations that we've written down. It's the same rule, except we have written out the rules for each of the sides. We've written it out where A is the subject, when B is the subject, and then when C is the subject. We'll understand this better if we look at an example. Given that we have a triangle with sides 7, 8, and 12, we want to find alpha, the angle alpha. So we need to know whether we're using the sine rule or the cosine rule. The first thing we want to do is assign letters to the sides and to angles as well. So let's call side A 8. Let's say side B is equal to 7 and side C is equal to 12. That means that angle C is going to be here, and angle A is going to be here, and angle B is in fact alpha. So let's consider using the sine rule. Now the sine rule says side A over sine of angle A is equal to side B over sine of angle B is equal to side C over sine of angle C. Therefore, 8 over sine of A is equal to B over sine of alpha is equal to 12 over sine of C. Now we want to find alpha. So if we look at these two, B over sine alpha is equal to 12 over sine C, we'll notice that we can't use this equation because we have two unknowns. Alpha is unknown and C is unknown because it didn't give us what the angle C is. If we look at this pair of equations, 8 over sine A is equal to B over sine alpha, A is also unknown and alpha is unknown. So therefore we have two unknowns, so we can't use this equation. So in this case, sine rule is not going to help us figure out what alpha is. So therefore that means that we have to use the cosine rule. Let's refresh what the cosine rule is. A squared is equal to B squared plus C squared minus 2BC times the cos of angle A. In our case, the angle that we're looking at is going to be angle alpha. And angle alpha is between the two sides, 8 and 12. So therefore, B squared is going to be equal to A squared plus C squared minus 2 times AC times cos of the angle that's between the sides AC, which is alpha. And now we fill in the numbers that we have. B is 7 squared is equal to A is 8 squared plus C is 12 squared minus 2 times 8 times 12 cos of alpha, which we're trying to find. Now let's do some arithmetic. 7 squared is 49, 8 squared is 64, 12 squared is 144. Minus 2 times 8 times 12, 2 times 8 is 16, times 12 is 192, so minus 192 times cos of alpha. 64 plus 144 is 208, minus 192 times cos theta, sorry, that's cos alpha. And therefore now we can take 208 from both sides to get negative 159 is equal to negative 192 cos theta, sorry, cos alpha. And now we can divide both sides by 192, that's negative 192. So now we get negative 159 over negative 192 is equal to cos of alpha. That is 0.828 to 3 decimal places, and that's equal to our cos alpha. Therefore, if we want to find by alpha on its own, we're going to use cos inverse. So cos inverse of 0.828 is going to be equal to alpha. We're going to plug that into our calculator, and we get that alpha is equal to 34.09 degrees to 2 decimal places. So in this case, we had to use the cosine rule instead of the sine rule, because we only had one unknown, and we get our answer to be that alpha is equal to 34.09 degrees. Let's look at one last example. We can use the same example, find A, that's angle A, if alpha is equal to 34 degrees. So now we have 3 sides that we know and 1 angle that we know. So let's see if we can utilize the sine rule. So once again, the sine rule says that side A over sine of angle A is equal to side B over sine of angle B, which in this case is sine of alpha. However, we know that alpha is given as 34 degrees, so we can substitute alpha to be 34 degrees. And that's equal to side C over sine of angle C. Okay, we can replace A with 8, B with 7, and C with 12. We want to find sine A, so the best equation that we can use are these two. Sine A is unknown, but we know what sine of 34 is. We can find that value, and 7 and 8 are numbers that we know. So there's only one unknown, which is A. So we're going to use this pair of equations, and we're going to follow through. The first thing we want to do is punch in what is sine 34 in our calculator. Sine 34 is equal to 0.56 to 2 decimal places. Then we do a little bit of arithmetic and cross multiply to get that 8 times 0.56 divided by 7 is equal to sine A. Let's work out what our left hand side is going to be. Works out to be 0.64, and that's equal to sine A. And now we need to find for A, which means we need to use sine inverse. So sine inverse of 0.64 is going to be equal to our angle A. Our answer works out to be 39.79 degrees. Our answer is correct to 2 decimal places. That's it for today's lesson in trigonometry. For additional videos, as well as information on the services we offer, or for an in-depth explanation about trigonometry, please visit www.limitlesslearningtt.com. You can email us at limitlesslearningtt@gmail.com, or you can always call us at 868-354-3115.